right, so we've got a question here that deals with graphing a quadratic equation, which if you're not familiar with them, they're going to involve a curved sort of graph. And we're starting out with a formula that looks like y equals x plus a times x plus b. And I've just drawn an example over here showing potentially what we could be looking at. And in this situation, we'd intercept the x-axis here and here. So we intercept the x-axis when y equals 0. So really what I'm asking is, at what points for x does y equal 0? And if we look at this situation, look at the formula, that's going to occur if either x plus a is 0 or if x plus b is 0. Since if one of them equals 0, it'll knock out the other one through multiplication, since anything times 0 equals 0. So what would make this first one 0? Well, if x equals negative a plus a will equal 0. And in the same way, on the second one, if x equals negative b, that would wipe out the second equation, setting the whole thing equal to 0. So I'm really concerned with what are a and b equal to? Because if I have those, then I have the 2 points for x for which we'd intercept the x-axis with y equaling 0. So I'm really saying, at what 2 points can I plug in x and get a 0 out for y? All right, looking at statement 1, I know that a plus b equals -1. But there are so many different options for that. It could be 5 plus -6. It could be 50 plus -51. So I have no idea what two numbers added together equal -1. And for that reason, I've proved that this is insufficient. So statement 1 is dead to me. Statement 2, I now have a point x, y of 0, -6, which means in my original equation, plugging in -6 for y and 0 for x, I find that this means -6 equals a times b. So I have two numbers that when multiplied give me -6, and when added together give me -1. Now there's only one pair of numbers for which this is possible, and that pair of numbers can be found by looking at the factors of -6. So we know that it's a positive times a negative because we end up with a negative number, and the factors of 6 are 1 and 6 and 2 and 3. And I'm ignoring decimals here because we're working with nice whole numbers and it looks like it's going to work out. So if I look at these situations, which of these two, if I make one of them negative and the other positive, will add up to a -1, meaning there's an absolute value difference of 1 between them, and the one that is more negative has the larger absolute value. So the only pair that has a difference of 1 is 2 and 3, and that means that we need the 3 to be negative so that when we add them together, we get something less than 0, we get -1. So using the two equations together, I'm able to solve this problem. But looking at statement 2 on its own with the -6, I had multiple different options, meaning I don't know which it is, and so it's insufficient. So the answer here is C. When taken together, these two pieces of information are sufficient to solve the 2 points at which we hit the x-axis where y equals 0. And to be clear, the 2 points are, since we know that a and b are equal to 2 and 3 and -3, the answers for x are -2 and +3. And the points are 3, 0, because the y has to be 0, and -2, 0. But obviously, because it's data sufficiency, we don't have to solve it all the way out. So I'd recommend that once you know you can solve it, you should hit answer choice C and move on from the question. But this is just a more technical look at it, and that is all the way through how we could solve this question and how to visualize it mentally.